Hi, everybody, and welcome to this week's episode of Packet Protector. Not Pocket Protector, but Packet Protector. I'm Jennifer J.J. Manella, here with Drew Conry-Murray. You can call it Pocket Protector if you want to. There's no public stonings here.
If you want. Yeah, we're not going to know.
No. In episode 70, a few weeks ago, we talked about Microsoft rethinking kernel access for endpoint security like CrowdStrike and all of the other EDR vendors. And we wanted to talk to somebody who had some insight on the role of the kernel in the operating system and, moving these security tools from the kernel out into user land and the benefits and trade-offs of that. And a listener raised their hand.
Yeah, so Dan Massameno reached out to us. He is the director of network and cloud architecture at Yale University. He's a longtime network engineer. He has experience in switching, VPNs, firewalls, remote access, and network design. And after the CrowdStrike and Microsoft outage, Dan wrote up a white paper and gave a presentation to his colleagues at the university about the event. And as part of that, did a lot of research into kernels. So he said, hey, I've got some information. And so he came on and we're going to pick Dan's brain on things like why security software would run on the kernel, the pros and cons of that, why it's now being moved out, how that's going to work, the future of endpoint security, Microsoft's Singularity project and what happened to it, and what's happening with Rust, the programming language, and why you might be seeing more of that in the future. Yeah, Dan, so thank you for being here. Thank you for raising your hand and volunteering. We love that. And it's also nice to know people are actually listening to the show. That's also positive. It's a good thing. But let's start with some basics. So
there's at least one of you.
We found him.
Just kidding. We found him.
So we're talking about operating system kernels. What does that mean? What is the kernel's role and function in an operating system?
Yes. Well, yeah. Thank you very much for having me on. And as a quick opening disclaimer, I don't represent my employer or the vendors. The views expressed are my own. Mm-hmm. But yeah, the operating system kernel is one of my areas that we look at sometimes. It doesn't come into network engineering too much, but it's important to know. Yeah, because we all use PCs. The main components of the kernel, I would probably, and there's always debate about this. It's kind of like talking about religion or politics at the Thanksgiving meal is what does this mean? But I would say that it's process memory management and it's the traffic cop controlling who can talk to what hardware. Mm-hmm. So if that's all that's in your kernel, you're probably talking about a microkernel versus if you've stuffed a bunch of other stuff in there, like the file system and the device drivers for your video card and all that stuff, that's more of a monolithic kernel. That's what you'll see in most operating systems nowadays. And some operating systems, they try to have microkernel type things like that. There's a protected lower layer. But by process management, we're talking about all the current operating systems that we use are preemptive multitasking operating systems, meaning the operating system's in control of what process runs next or for how long. Uh-huh. If you wanted to see a cooperative multitasking operating system, you'd have to go back to MS-DOS or pre-Windows NT, pre-Windows 95. So that's what process management is that the operating system is doing as you alt-tab between stuff. It's happening many times per second as it schedules things. Memory management is basically user mode applications are getting virtual memory, which we'll talk about in a bit. Uh-huh. And then the kernel manages the virtual memory and how it gets used in real memory. So once you've kind of talked about those three core things, then your engineering decisions are about what else goes into the kernel. The printing subsystem used to be in the kernel in Windows, and they moved it out for safety.
This is really air traffic control for your system resources, it sounds like.
Absolutely. If you had a single application operating system, like an embedded system or our really like 1980s operating systems, you wouldn't need to do multitasking. You just ran one app. But that's not our current reality.
Oh, those were the days.
That was back in the day. Yeah, but the graphics subsystem used to be in user mode, and along some version of Windows NT, they moved it into the kernel for speed. So there's always been things moving in and out. Mm-hmm. It's in flux over the years, and it's an interesting balancing act, is what I would call it.
And you said something else, user land applications. In the drawings I've seen about, the kernel and stuff, there's usually this line, and there's the kernel on below, and then up above is user land. And why do we have that separation?
Yeah, so we're going to talk about why that is. So in kernel, sometimes people refer to it as ring 0 and user land as ring 3. And that's referring to how the Intel CPUs refer to it as ring 0 is the underlying underpinnings. It's the kernel. And ring 3 is where user applications, like, whatever you're running in front of you is running there. Almost nobody remembers what happens to ring 1 and 2. I read somewhere OS 2 used them for something, but
I was just going to ask, is there a ring 1 and a ring 2? And
There is. I think Intel is about to, or they have in some models taking it out or deprecated it. So it's very historical. Nothing uses ring 1 and 2 that I know of. Well, there's plenty of stuff I don't know about, but yeah, I don't think anybody uses rings 1 and 2. It's ring 0 and ring 3.
You're using DOS in a lot of Windows examples. Is this kind of the same model that we have both in Windows and Linux, or is this very specific to Windows itself?
No, it's not specific to Windows. Linux and Mac OS, which has a lot of Linux heritage, both use these concepts that there is a privileged, and the rings, ring 0, ring 3, are really what controls how the operating system protects itself and protects applications from other applications. Meaning you can't get the other stuff done unless you're running in ring 0. You can't manage the memory mapping tables, mapping virtual memory to real memory, unless you're in ring 0, your code running in ring 0, which should be only the kernel code. You can't control who has access to the hardware, the stuff on the PCI bus and stuff, unless you're in ring 0. Ring 3 stuff, code, should not be able to adjust how virtual memory maps to real memory.
You said should. Does that mean it happens?
Well, anybody can say that I found a bug in the microcode inside modern Intel processors that violates the principles that they set down. But other than that, yeah, you're talking about the microcode that's running inside the CPU, not even in the assembly language that gets compiled and run on the CPU. So there shouldn't be bugs in that system. Otherwise, it'd have to get fixed real fast because it would compromise the underpinning of the entire modern IT infrastructure everywhere.
And just to clarify, so we have this separation, you said, to protect applications from other applications, and I assume it's also to ensure that one application just doesn't use all of the resources of the host machine. That's why we have this process management and memory management in the first place.
Yeah, what you want to do is you want containment so that a bug in one application can't crash another application. You want containment for malware reasons too. So if an application is malware, you don't want it affecting the kernel and you don't want it affecting other applications. And you touched upon it, throttling. So you might have a policy inside the operating system that says, well, this application is not in front of the user right now, so I'm not going to let it consume all CPU time or a whole bunch of CPU slots. It's going to get demoted to a lower priority. It's going to get less CPU than the thing that's right in front of you. So those kind of things are happening in all modern operating systems. Absolutely.
You also mentioned virtual memory and real memory. How are those things different, and why are operating systems using virtual memory?
So that is probably of the three, maybe that might be the biggest one. So let's say you start up Notepad on your Windows machine and it's a 64-bit application, which means we're talking about 64-bit pointers in the application that's pointing to memory positions that says this is the start of a 20-byte string. It's in position this, position 8 or position 17 trillion or whatever it is. Meaning Notepad thinks it has from 0 to 16 quintillion bytes of memory that it can access. You don't have that much real memory, but it thinks it's got a 64-bit pointer. It's got the whole memory space to itself, and it's partitioned, and the operating system might say you can use this much, but that's the pointer. And applications use pointer to identify where the bits are in its application. Then that virtual memory space gets mapped page by page into real memory. And the operating system running in the kernel at ring 0 is the thing that does that mapping. And we're heavily simplifying the situation because modern operating systems do a lot of tricks here. So for instance, if my machine has 64 gigabytes of RAM, real memory, but I need more than that, it might page things out to a page file on your hard drive and then swap them back in as the memory pages need to be used. Because if it's not in real RAM, you can't use your hard drive as RAM. You have to page it back in. And then that paging strategy, that caching strategy is critical to good performance of a system. And that's all happening. It's all invisible to what Notepad sees. And most importantly, if Notepad tries to scribble onto memory pages that is a bug or it's malware or it tries to put bytes down into the memory space, it can't affect other applications because the other applications are seeing a completely different 64-bit address space because they're virtual. It's not real memory, and it can't scribble into memory locations that the operating system is using in the kernel. So that's the huge part about how we're segmenting applications, keeping them from crashing the rest of the system. When you see a blue screen on Windows, something in the kernel, or it's either something that was written by a third party that's running in the kernel, like CrowdStrike or my NVIDIA graphics card driver, or it's something Microsoft wrote, one of the two, because no matter how badly written Notepad is, or Microsoft Word, or Adobe Illustrator is written, it can't blue screen the operating system because it can't destroy the memory structures of the operating system because it can't access them.
Because the memory management function of the kernel is essentially acting like a buffer or a protective layer and saying, you think you have this much memory, but I'm actually controlling how much real memory you get access to.
Yeah, and where those memory pages are mapped to, so that I could be writing to position 14, but you're mapped to real position 92 billion, and that position isn't even adjacent. It doesn't overlap anywhere with other memory pages. It usually does it page by page, not byte by byte. So there's a lot of things that go into a modern operating system. Really, really smart people that design these things to optimize for the hardware that we have today. I mean, it's amazing what actually gets done at the speed it gets done when you're just looking at all the windows that are open on your machine, and it's all happening in the background, invisible to the actual applications.
You mentioned the example. So we know that a lot of the security tools, at least for now, in the Windows and I think Linux environments do have hooks into the kernel. You mentioned something like the NVIDIA chip or driver. What other types of applications do have hooks into the kernel currently?
So, for instance, I believe, so I don't work for Microsoft, but I believe the file system runs in Ring 0. The disk drivers that the file system uses to write files to and from, it's all SSDs now, but we call them hard drives still. The drivers that allow you to write bytes out onto the wire with your network card is installed. And they move things around for safety. It used to be the printing subsystem was in there. And then finally they said, this is dumb. We don't have a performance problem if it takes an extra half a second for this thing to work. So they moved it out to user land.
Yeah.
So they're constantly making those engineering trade-offs.
And you mentioned the CrowdStrike thing, and that was one of the, I think, precipitating events that kind of led Drew and I to talking about this. So for everybody that didn't catch the news story, which was, I think, several weeks ago at this point when we re-talked about it, can you give us like the little short thumbnail of what happened? Because I want to talk about that. And then I want to talk about sort of the trade-offs, because the conversation since then at the end of last year or Q3 of last year has been the industry, Microsoft and all the security partners trying to determine, are they going to keep letting their partners all live in the kernel for security and endpoint security tools? And some of the conversation I've heard, and I think probably what you heard that prompted you to raise your hand with this is, what are those trade-offs and benefits? Because, on one hand, I hear, people that know way more than I do, but they're arguing with each other because some of them are saying, well, you need to have hooks into the kernel if you're going to actually secure the whole platform and you're going to be the primary security mechanism. And then what we're hearing from others is, well, Apple and some other operating systems don't let you do that. And there's certainly ways around it. So I do want to talk about the pros and cons and the benefits. But first, let's give everybody listening like that little short thumbnail of what happened with CrowdStrike and Microsoft last year.
Yeah, last year, CrowdStrike, basically, they released an update and they push all their updates out automatically on the fly to accommodate day zero events and stuff like that. They released an update that had a bug in it. Any human that writes software, software's going to have mistakes in it. You have to assume that there's mistakes. And the CrowdStrike driver was running at Ring 0 in the kernel, and it was marked for run at startup. And that's what created the final, what actually happened, which is the machine wouldn't even boot. You couldn't even boot the machine to get into control panel and delete or remove CrowdStrike, because they marked it for boot up, presumably because they wanted to be first in to get into the operating system and running on the system before userland starts up. And so if malware was going to start up after that, it would be there to monitor and see it start and say, hey, no, hold on there.
Yeah, this wasn't a nefarious action. That this was a security decision. Like, we want the security software to be the first thing to run inside this environment.
Yeah, we want to start running. Our process has to be running to monitor the malware.
Yeah.
So we got to start up when the machine starts up. So they basically made an architectural engineering decision that, you have to be prepared to take $1 billion hit to productivity across the planet for a decision they made. I mean, they could have decided not to do that. Like, oh, that's too dangerous. Let's not run at startup.
They also could have rolled out update rings.
Well,
they could have slow rolled it so that they didn't just hit millions of systems at one time. And I think that's actually one of the requirements Microsoft put in place moving forward.
Yes. That is a whole nother issue. Ring 0 versus Ring 3, who cares, right? If they had staged it or triaged it or something to different areas.
Green blued it, yeah. Uh-huh.
Or if I could have told them, my organization is healthcare, can you put me on the second tier of rollout or public safety? Sure. That would have been a whole different thing. Aside from, you could run at Ring 14 for all I care. It would have been nice if they had staged it better. So when I say they made engineering trade-offs, essentially, so the benefits of running as a user application, a user Ring 3 application, is containment, containment of bugs, containment of malware, throttling, which we mentioned, is all easy at Ring 3. The trade-off is, and this is what the malware software is doing, and this is why your NVIDIA graphics card runs in Ring 0, is at Ring 3, your application will run slower than the kernel components at Ring 0. Because every time you go to do a transition from 3 to 0 and 0 to 3, you pay a performance penalty as the CPU goes, oh, wait, let me put the notebook down and grab another notebook and start this other process. Then that context swap causes you some latency. So every time a user application goes to send a packet or access the file system or draw bits to the screen or something, you have that context switch from 3 down to 0 and then from 0 back up to 3. And if you want to dodge that performance, hit, you write your graphics device driver to run it in kernel space.
So, but I'm assuming too, maybe this is a bad assumption, but if a security tool like an endpoint security, CrowdStrike, whatever, is not running at the kernel level, it does not have the benefit of that whole let me spin myself up first and make sure everything is safe and secure, right? Like, let me secure the building before everybody comes in. So what is the security fall off if we move it to user space?
Yeah, well, I think what also you get in Ring 0 is access to private data structures that only the operating system knows about. So from Ring 0, you can see every process that's running on the box. You can see the memory layout of every process, like how that process's virtual memory is mapped to real memory. You could see if there's any inter-process communication going on. This is stuff that, my Microsoft Word instance is not going to see what's going on between Adobe Acrobat and the file system, but the kernel sees it.
My understanding is that access to the kernel, that's what a rootkit wants, because it can, manipulate. If you have antivirus software, for example, running in user land, the rootkit with kernel access could manipulate that antivirus software to essentially Jedi mind trick it and be like, yeah, I'm not here.
Oh, yeah.
Mind trick it. Well, and that's why I'm asking, if we move a security tool out into the user space, I want my security tool to know what all's going on. How does that happen then if we've moved it?
So reading what Microsoft is doing, actually Mac OS has these APIs as well. And I don't know what Linux is doing, but basically if Microsoft builds an API that allows a user land application to see, say, the virtual memory to physical memory mapping, I'm just guessing at what they're going to offer the security vendors or what security vendors, that's the secret sauce that they don't publish, right? Microsoft could build an API to allow a user land application to query the operating system and says, hey, give me everybody that has a pointer to the memory space of the file system, or tell me all the processes running and where their start and end points of all their memory pages and how they map into real memory and things like that only the kernel would know and the user land application would never know unless they had an API to tell them. And I found it interesting that in the blog that Microsoft announced this new API, they mentioned a couple vendors. They mentioned CrowdStrike, but they also mentioned ESET, and they mentioned Trend Micro and a couple other vendors. So my strong suspicion is this is not going to be an API that you can just use if you wrote an application and published it on the Microsoft Store. You probably have to be a special company that has signed a special licensing agreement with Microsoft, and you need to have a signed application manifest from Microsoft that has an endorsement on it that says I can access this API. Otherwise, that would be dangerous.
Yeah. And here's where I think I'm wrapped around the axle with this is, I like the idea of, protecting the kernel and moving things out. However, I'm also kind of feeling a little sketch about it because, okay, let's say we've got APIs and they're everything you just described, right? You've got this relationship. Microsoft has created and published these APIs. You have the relationship, et cetera, et cetera. So that then presumes we know what we need to look for. Microsoft has built an API, exposed it to us, and we've updated everything. So I feel like if there's some malware or some new, TTP that we need to be looking for something a little bit different, or if these endpoint security vendors have their own secret sauce about what they're doing in the kernel and things that they're looking for, and that is their differentiating value, whatever AV company versus, EDR company B and C, if they're doing things differently, that's what makes them better in that way. But if everybody's using the same APIs and you have to wait until they're published from Microsoft and you have access to them, what is that going to do to our response when there's new malware?
Everything you just said is true. So I suspect that whatever memory structures or internal cataloging of things that is not available in the API now, in 9 months, the vendors might go back to Microsoft and say, hey, can we do version 1.1 of this API? I need access to this memory structure or this data structure to be effective. I suspect that will happen. And it probably won't be blog worthy, or we won't see a news, because that will be boring news. But I suspect it'll evolve to meet the needs of the security company ecosystem. And then the other thing probably there's a lot of value add they can add with the whole heuristics of analyzing what patterns of things are happening. And so all those smart people at CrowdStrike or Trend Micro or wherever, they're doing jobs that are really looking for patterns. And I'm sure they're adding AI agents or some such nonsense to detect patterns that their human programmers didn't anticipate trying to look for, but that the AI might be able to find is certainly, it might be just machine learning, but you have to say AI because that's how you get the VC money. I'm sure there'll be differentiation around how much they charge you and the consulting services to light it up at your large organization. So I don't worry about them making money and figuring out a way to sell it to me. But I think you're totally right. There probably will be a version 1.1 and a version 2.0 of the API so that they can get their jobs done.
I wonder if there's a future where, endpoint detection company X goes to Microsoft and signs, an agreement with their intellectual property and wants a specific API that they're not allowed to expose to the other vendors. Like, you know what I mean? Are we going to be in this weird world where there's almost like we have different code chains in some of the infrastructure stuff? Are we going to have different API chains for the different EDR tools because the vendors want to keep their secret sauce and find a way to get that from Microsoft? And Dan, do we trust Microsoft? Because I feel like, and now I'm a Microsoft person, I'm a Microsoft Android person, I'm not an Apple person, but they've not been doing a fantastic job with a lot of their solutions and platforms recently. And part of it is like, I've lost a little bit of confidence and I think I'm getting this, whatever this is, I've asked for this information or this configuration. I think it means this thing, but Microsoft have scoped that differently. And out of the 100% of data points that I think I'm getting, they're actually only giving me 85 of that. But I don't know, I can't see it, so I don't know that I'm missing 15%. So I just kind of feel like this could go off the rails quickly.
So I think that, anything could happen, but I think Microsoft's behavior or what they end up doing is going to be bounded by that European Union agreement, which is kind of what started this because Microsoft was not granting the security vendors access to some of these underlying memory structures and internals. And then the EU decree said, oh, but your own Microsoft security product has access to this stuff. And that's not competitive. That's anti-competitive. So you now have to grant all these third-party security tools the same kind of access that your own Microsoft-developed security tools have. And that's when Microsoft kind of broke down and said, okay, security tools, you can be in ring zero and access these memory structures and these underlying stuff. And that led to the demise of the whole debacle last year.
And that's how we got to CrowdStrike eventually.
Yeah. Can I poke into that for a second? Because I want your opinion on this too, and Drew's.
Yeah.
Because one of the things was, Apple keeps them out of the kernel. I think Drew and I both, back when we were researching this at the end of last year, like we did read that European Union lawsuit basically, or whatever they put in place. So we kind of scrolled back through that. But one of the things, so I guess the question was, if Apple could do that, why couldn't Microsoft? What's the differentiator? Does anybody remember? Was it because Microsoft had a security product that they charged for and therefore it was unfair competitive advantage? Because Apple does some of its own Apple sprinkle stuff, right? They pat you on the head and go, oh, don't worry, we will take care of your security for you. But is it just simply because they do that and don't charge separately for it?
It's probably because the EU decided it had a bone to pick with Microsoft.
Well, that's, yes, layers 8 and 9.
Yeah. Let's not ascribe to these people more than they should be, which is probably they are just had a bone to pick, had a problem with Microsoft that year. And then if they were having a problem with Apple, they may have done the same thing to Apple.
Yeah, true.
Yeah, that's what I think it is Apple's not selling me Apple's own branded endpoint security software, so they're not running afoul of this EU competition rule.
Okay.
Yeah, so because of the EU ruling, I think that Microsoft is going to probably play it safe and have a quote-unquote open API, meaning it's just open to the main players that have been licensing this API, but that it'll be uniform across all the players. It'll be the API that Microsoft's own security tools use.
Right.
And then they'll hopefully not catch the ire of an EU regulator again.
Yeah, my assumption is if they're trying to avoid running into regulatory issues again, that whatever Defender is getting out of the API, legitimate third-party EDR vendors should also be getting.
And this is to our advantage. For us, the end user, this is good for us because we really do want as little as possible running in the kernel. Our modern day societies run on computers.
But I also don't want malware running in the kernel.
well, this is why malware tries to trick you. It brings up that Windows security notice. The whole screen goes, dimmed out with that notice on the front of you. Say, hey, you were about to change a system. I forget what the wording is. Do you want to proceed? And then you're trained to say either yes, because you wanted to install that software, or no, I didn't realize I was installing anything. I just clicked on this link for Rolex watches and I didn't realize what's about to happen. And you should say no.
Rolex watches. Dang, Dan's high rolling over here.
But I want the Rolex that only cost me $120.
Oh.
So that's a sketchy Rolex.
Those relax watches instead of the Rolex watches.
So, yeah, if malware can get by the human and get installed on your system, and I don't know what you would, so I'm not a malware vendor. I don't know what you would have to do to get installed on the system and get into the kernel space. I have no idea. They try to find a way. And then the awesome place to be is if you can get installed, like there's malware that can exploit and install itself into the system BIOS of the motherboard.
Yeah, I've heard about those.
Then your malware has booted before the operating system and before the anti-malware software that's marked to start at boot. So you're ahead of all those people.
That's a Jesus take the wheel moment right there.
That's just throw the machine out. Some people have called that ring -1. So ring -1, there's these rings that have come into nomenclature for hypervisors, and the stuff that runs before the hypervisor would be your motherboard BIOS.
I keep hearing, so Microsoft has, recently announced lots of, changes and things, this being one of them. Supposedly the 24H2 rollout is fundamentally and substantially different than some of the prior versions of 11 and 10. Is this impacted by that version?
So this was an interesting point that I saw, I think the same week that I heard your Pocket Protector podcast. So I wanted to add it in. But to give it context, there's a little fight brewing within the Linux community.
Oh, we love fights. As long as there's somebody else's fight, not our fight.
Yeah, and all of us have opinions. So, IT people fighting over stuff is hilarious to watch. But in the Linux community, that's an open source project, and there are developers that write kernel code, and some people want to introduce the Rust programming language into the kernel. Now, Rust is a new programming language that is what they call type safe and memory safe. But the Linux kernel is, historically been C and C++ language. And the C language started in the 1970s, back when compilers were super simple. And the C, you could do anything, including shooting yourself in the foot with bad programming. And C, you can change the pointer arithmetic used to access memory and just move it around and write into other locations and do anything you want, which is kind of what you want to do in an operating system. And people want to use Rust or something like Rust because Rust is at compile time, memory safe, type safe. It stops you from writing into bad memory locations as you compile the software so that it runs correctly.
What's type safe?
So meaning if you, the programmer, intended for something to be a long integer, you can't trick it via accidentally introducing a bug or malware to consider it a string.
Okay.
And if it's a long integer, you can't stuff a extra long integer in there, which would write over the end.
Okay. Like a variable input type.
Yeah, well, this is super important because I think probably a lot of our listeners have heard of buffer overflow attacks.
Yep.
Oh, yeah.
If you look at the malware and the exploit, the compromised software out there, it's almost all buffer overflow stuff. You had 20 bytes to write a string and then accidentally or through malware writes past the 21st byte. And now you're running into program space that was not intended to be written into. And that's how malware gets into stuff. You got integer underflows, which I learned about this year. I didn't know there was such a thing. That you could have an assigned integer that loops around, and if you keep adding and adding, the integer gets bigger and bigger and bigger until you add to the last bit, and it can get no bigger, and then you add one more, and it loops back around and makes it a negative integer.
Oh, okay.
That's all basically bugs, or some malware inventor discovered that the bug in your software that does that, it can use to compromise the system. And with these modern programming languages like Go, Rust, I'm not a programmer, but like C#, these will stop those kind of memory access errors at compile time. It forces you to write, I was going to say good code. Like it forces you to write correct code, air quotes around correct, meaning the compiler saw that you were trying to write into 20 bytes and it won't let 21 bytes get written to that at compile time.
It takes one bullet out of the revolver before you play roulette.
A huge bullet, because buffer overflows are almost everything nowadays. And so these languages, C Sharp, Microsoft has C Sharp and Go and Rust and Java. They're trying to fight this battle at compile time instead of at runtime. And I fully support the Linux community's desire, those people that want to introduce Rust into the operating system. I personally think it's a great idea because the other people fighting to just keep it C and C++ are fighting because if you introduce another language into the kernel, you've created a disruption where you're making things more complex and more difficult to scale and troubleshoot, which is totally true. If you just write everything in C, that's easy. But I think we need it because we live in a world where we have to rely on these systems working correctly. And if the caveat is, oh, you can use C++ as long as you follow good programming practices and you don't screw it up. Well, humans screw stuff up all the time.
Right.
So
those are some big caveats.
those are huge caveats.
Is this introducing a new language at that level is something that Linux is doing, something Microsoft is considering? Who's doing this?
I think the Rust people are succeeding in introducing some Rust into the Linux kernel. I have to check. I know that was an ongoing debate, but I just found it really interesting that in the in-depth IT notes of the release notes for Windows 11, they call it 24H2, released the second half of 2024, that they have now introduced Rust into the Windows kernel in a small piece called the graphic device interface. And I thought, oh, that's not making news, but it's funny that they're slowly introducing the thing that this big fight is happening over in the Linux world. They're slowly introducing it because I haven't seen very many news outlets talk about this. They just kind of slid it right in there at the bottom of these pages and pages of release notes. And I support their efforts to do this because we need strongly control. If you can stop a certain class of bugs from entering into the software at the compiler level, the bug never even ships to the customer, never gets there, because it compiles correctly.
Right.
Yeah, I mean, like in 2025, I think, because you're right, so many of these vulnerabilities we see are due to buffer overflows, and we're just like, come on, guys. Like one of the easiest things to prevent that's just not even 101 level, it's more like kindergarten level. And yet still in 2025, after we've known how to solve this problem for 30 plus years, 40 years, it's still there.
Microsoft actually created a brand new operating system from scratch called Singularity, and it turned into an incubation project under a gentleman by the name of Joe Duffy called Midori. And it had been written from scratch with a C# variant to be memory safe, type safe, and it introduced some really cool elements like asynchronous communication between processes that were type checked and no shared memory pages. Some really interesting stuff. And around 2007, they finally killed it. I think because they thought it was too ambitious. There was zero backwards compatibility. When it was Singularity, I don't know what it was in Midori, but when it was Singularity, it was just a command line interface, which is a non-starter for any modern operating system. So it had to be really built up from scratch, and they killed it. Interestingly, in that same year, 2007, another software company introduced different technology that had zero backwards compatibility, no user base, starting from zero. Any guesses what that product was?
Well, I saw your deck, so I know, but I want you to do the big reveal.
JJ. In 2007, that was when the iPhone was introduced.
Oh.
And I would hazard to say that was a successful product. Probably most people would consider that a successful brand new product. So I think there's appetite, or there's the ability to introduce a completely new product, like a completely new operating system built on modern design principles that did not exist in the 1970s.
I mean, if I'm, running airline IT systems, that's all running old code, and backwards compatibility is important to me, so a brand new operating system isn't going to make much difference in my life. But then I thought, well, we're seeing lots of new applications being built in public cloud using cloud native, constructs that have nothing to do with traditional operating systems, and it can happen. And yes, you have to sort of run this bifurcated environment, but if there are benefits to it, people will eventually adopt it. So yeah, it is too bad Microsoft didn't go that route.
Yeah, Google had an operating system that they're still maintaining for some home products called Fuchsia. It wasn't as ambitious as Singularity, but it did redo some of the security principles that exist in modern operating systems. It handled security differently with a fresh look on it. So that's an interesting operating system. They were going to target it at like Chromebooks and like a general purpose operating system. And I think it only lives in its Nest Hub or some home product that's an IoT product. So I think the major operating system vendors are just playing it safe now. They're not introducing something completely new that's from scratch. And there's value to that because then they can keep moving forward with every single application that you've ever loved and wanted.
Yeah.
But it's built on 1970s technology.
Right.
It literally is. That's where all this stuff came from, is that research in the 1980s. And it's showing if we think about it, SMTP is a garbage protocol, and we can't get rid of that thing. So that's why the momentum of these systems carry us forward. And we have
Wait. Which one's the garbage protocol?
the simple mail transport protocol.
Oh, SMTV. Yeah.
That protocol completely has seen its day. It's absolutely not fit for purpose for 2025. We can't get rid of it. Or no, people don't want to get rid of it. So that's why these operating systems exist, and they can keep slapping layers of paint on top of it and making improvements. Like if Microsoft introduced Rust into the operating system, or if they have a new API that moves security vendors into the Ring 3, great. It's good moves. We're still dealing with the same operating system, unfortunately.
I have to ask you, because your title is Director, Network and Cloud Architecture at the university. How did you get so geeked out on platforms and operating systems?
By not having a social life. No.
Welcome to the club.
So like a lot of people in the university system, I graduated from the University of Connecticut, and you don't learn about real things for a real job at a university. You learn about concepts and underlying architectures and how a conceptually pure SQL Server database organizes data. And then you realize that none of that matters when you go to install Microsoft SQL Server. So this kind of stuff is fascinating to see the transition over many decades of the stuff. And also, I'm a crotchety old man, so I'm saying, burn it down. The emperor wears no clothes. Why are we still using these operating systems? And that just fits my personality.
So instead of, hey, you kids, get off my lawn, he's like, come on over and let's have a party and burn this crap down.
Well, I have to reboot my machine because I get Patch Tuesdays, the patching every month that comes from Microsoft. So if you imagine, if it's in the kernel and you need to patch it, I could appreciate how you might want to reboot that operating system to get the patch in there because it's running in the kernel. But why are they patching the kernel? The kernel should be this small piece of code underneath everything that should be pretty much done deal. Like, how many bugs are they discovering in the kernel? But on the flip side, if they're patching something that we found an exploitable thing in the software that is the printing subsystem, why am I rebooting? Because that's not part of the kernel.
Yeah. They did also announce recently that I don't know if they have it now or it's coming, that they're going to be part of their resilience program, their Windows Resilience Initiative, WRI, something like that. One of the things was we're going to be doing, I'm going to use my words, they're going to be wrong. So sorry if you work at Microsoft and I completely butcher this, but basically we're going to do tiers of different types of updates, and they're going to be more readily available faster and not require, at least certain security patches are not going to require reboots, and they're going to be kind of seamless, like micro patches, basically.
Yeah, I love it. They should do that. So that's great. That's another great move on their part. Windows, back in Windows Server 2008, they had a version of Windows Server called Windows Server Core.
Oh, yeah.
That was basically a super stripped down Windows Server. And the claim was you're only going to really need to reboot this maybe once a year because the core has been designed. We're not updating that thing. The core doesn't include all this other frivolous upper layer stuff that might need to be patched because it's just the core. So if you build your application for Windows Server Core, then its uptime is going to be great. And they killed the product. It evolved into something else. They don't call it that anymore. And I think it's evolved into something different now for containers or something. Windows has a version of Windows called LTSC, the long-term servicing channel, that it's supposedly built for IoT devices or MRI machines or ATMs. And it's the long-term servicing channel because they commit to supporting it for 10 years. It gets updated much less frequently, and it does not have all the new features. I think it might now, but for the longest time, it didn't even have the Edge browser in it. It still had Internet Explorer to give you a super stable, something you could rely on for 10 years version of Windows. They will actively stop you from buying this because they want it to just be for medical systems, industrial process controllers, air traffic control. That's how they target it to you, not as a general purpose desktop operating system. And I'm left thinking, wait, I want that for my general purpose desktop operating system.
If it's good enough for an MRI machine or air traffic control, right? It can run my applications.
Yeah, heaven forbid you bring up your start menu. You're trying to type in the name of an app you're going to run from the start menu, and you type it in wrong, and then it starts searching the web on you. And now I have stock feeds and what the Kardashians are wearing. I don't want that from my start menu.
Are the Kardashians still a thing?
I don't know because I try to flip right off of that so fast. My ADD, I can't have my start menu doing but one thing. And if I'm distracted,
I hate when I first installed this version, like it moved my search pop-up Windows icon, in the middle, and that was dumb. But then it just also started like down in the taskbar showing things that moved, like weather and news updates, and I'm like, what the crap? Like, just stop, just stop. And no, I don't need to play games. Stop showing me games. I'm not playing games. Uninstall the games.
And the crazy thing is, too, is the ability to search for that kind of stuff is one click to pull up the start menu and one click to run this thing called a web browser. I don't know if you've heard of it, where you could search for stuff if you wanted to learn about like the score of your favorite baseball team. Why you're baking that into my taskbar and my start menu, and they're going to beam it right into my neural implant soon, is beyond me. But I wonder what customers are going to Microsoft. I want this feature. I want my productivity users to be able to see what NASA has announced.
I want my productivity users even more distracted. Can you make that happen, please?
Who's saying that? I don't know. It's very bizarre.
So maybe as a question to wrap on, the whole point of this is talking about how do we get systems to be more reliable. So do we as end users, as customers, Dan, do you feel like have any leverage that we can wield to our vendors to be like, please, what are you doing about reliability?
I was suggesting to my organization that as we do new software purchases or we're negotiating for a software purchase, asking questions as a standard questionnaire. Are there any components in your piece of software that run in kernel space? Yes or no? What is it that you're doing? Does it auto update itself? If it auto updates itself, can central IT develop a policy that holds back updates until they've been reviewed, or can roll it out within my organization in a controlled fashion? Because maybe my organization wants it rolled out 5 minutes after it's released. And maybe we don't, but let me make that decision so that we can decide, maybe I do run an air traffic control system and I'd want to make that choice, that balancing act of I want the updates slower because I want to review them before they hit all these machines. I think I did read CrowdStrike has managed to build some of that into their updating system now because they just got slammed, right? They looked bad last year when this thing happened, and for good reason. So yeah, we shouldn't be taking the status quo from our vendors. They should be doing things better. We can't ask our vendors to write software that doesn't have bugs in it because that's impossible.
Sure.
So given that, how are we managing that relationship with the vendors that are producing these products for us? And our standards should be higher.
Well, Dan, thank you again for raising your hand and coming on to talk about this. This has been a lot of fun, really interesting and informative for me, and I hope for the listeners too. By the way, it's Packet Protector, not Pocket Protector, just so you know, but I get the issue. But are you online? Do you blog? Do you have books, anything you want to promote, or where can we find you?
So people can reach out. I have a LinkedIn profile that, Drew, I think you're going to link to.
I will.
Don't expect a fast turnaround because I don't check it very often, but that's probably a good avenue.
Okay. I can attest to that personally.
Sounds like you might have an invitation in your queue, Dan.
Yeah.
Great. So yeah, LinkedIn, we'll have that on there. And we've also had you on heavy networking a couple times. So, and you've written some blogs for Packet Pushers. So I'll drop those into the show notes that accompany this podcast. So thank you, Dan, for again raising your hand and being here with us. And thanks to you for listening. If you have a topic you want us to cover, or a comment or a correction or question, you can reach out at packetpushers.net/FU. We do love it when listeners reach out. And just to let you know, Packet Protector is part of the Packet Pushers podcast network. We've got a dozen technical podcasts for professional development on networking, security, IPv6, DevOps, and more. There's an industry blog, 2 weekly newsletters, our community Slack group, a YouTube channel, and an IRC group. You can find everything at packetpushers.net. Always free, always no login required. Thanks for listening.